way that we can evaluate limits is by doing so algebraically. Now, most of the time, 99% of the time, the easiest way to evaluate them algebraically is just through direct substitution. So to do that, we're just going to substitute in 2 for x. So this is just going to be 3 times 2 plus 5, which gives us 6 plus 5, which is 11. So the limit as x approaches 2 of 3x plus 5 is 11. Now, if we look here, the limit as x approaches 7, if we substitute in with this, we're going to get 49 minus 35 plus 6 over 7 minus 4. So this would be what? 14, right? 14 plus 6 is going to be 20 over 3. That looks about right to me. And if we look at this last one, we're going to substitute in -1. So -1 squared is just going to be 1 plus 5 plus 6 over -1 minus 3. So we're going to have 11/12 over -4, which of course simplifies to -3. And actually, if you graph all of these, you'd also be able to see that this is where these limits approach. Now, for this one, of course, it's going to be difficult to kind of find 20/3 on the graph. So that's why evaluating algebraically is going to be much simpler. Now, there are some that we're going to have that are going to be a little bit more complicated. So let's look at number 4 here. The dividing out technique. If we directly substitute in 3 for x, we can see that in our denominator we're going to get a 0. And that means that that's undefined. So really this isn't working. But we might still actually have a limit. So I'm going to divide this out, rewrite this as the limit as x approaches 3. And we're just going to factor the top. I'm going to leave that x minus 3 in the denominator. But x here. Looks like we're going to have x minus 3 and x minus 2. So if we do that, we divide out, we get the limit as x approaches 3 of x minus 2, and then 3 minus 2 is of course 1. If we look at number 5, we can evaluate this again by dividing out. And I rewrite my limit here. So I have x minus 4 in my denominator. X. Looks like we're going to have x to... Well, it looks to me like we can still only factor this way. Minus 3 minus 2. Now, if I substitute in 4 here, I'm going to get, before I even go into this, I'm going to get 16 minus 20, which would give me -4, right? 16 minus 20 is -4 plus 6. So I have -4 plus 6, I'm going to have 2 over 0. And even when I substitute in 4 here, I can't simplify anything out. So if I have 2 over 0, this tells me that I know that I have an asymptote in that graph. And if I have an asymptote, then my limit does not exist. Remember, our asymptote, it might look like this. It might look like this. You know, we might have something going the same direction. Who knows? It doesn't matter. It might be going to infinity. It might be going to negative infinity. It doesn't matter. Infinity, negative infinity, the limit does not exist. So that's what's happening here if we have 2 over 0. Let's look at another one. Here we have the limit as x approaches 2. Well, my denominator looks a little bit complicated, and maybe I can divide that out. And we are going to use division. We're going to use, oh, what is this called? I can't remember off the top of my head. I don't know why I wrote a -10 there. This should be a -10. This should be a -10 right here. That'll make things simpler. So if I divide here I'm dividing by x minus 2, so this is 2 here. 1 just comes down. 1 times 2 is 2. 1 plus 2 is 3. 3 times 2 is 6. 6 plus negative 10 is negative 4. 4 times negative 2 is negative 8. And that, of course, becomes 0. So we know that this is going to factor out. I wish I'd left myself a little bit more room here, but this is going to factor out as x minus 2 times x minus 2 times, and we just rewrite this, x squared plus 3x minus 4. So these are going to cancel out, and I'm just going to end up having the limit as x approaches 2 of 1 over x squared plus 3x minus 4. And if I substitute in for that, I'm going to end up having, what, 4 plus 6 is 10, minus 4 is just 6. So my limit here is 1/6. Now, the reason I know that I could do this is if I initially had substituted in here and I had 2, I would have 0. If I just, I'm going to kind of draw a line here. If I substitute in here, I'm going to get 0 over, this is going to be 8 plus 4 is 12 minus 20 plus 8. It looks like this is all going to cancel out. I'm going to get 0 over 0. If I have 0 over 0, I know that I have a hole in my graph. And if there's a hole, there's a limit, right? Remember, our holes look like something like this, right? There's a limit here. There's a hole. There might not be an f of x, but there's actually a hole. There is a limit that exists for this problem. Let's look at number 7. Now here we have the limit, this got a little bit smudged, of as x approaches 3, of 3 minus x over x squared plus 2x minus 15. Now, if I substitute in 3 right away, let's see, does our limit exist or not? If I put in 3 over here, I'm going to get 0 over 9 plus 6 minus 15 is going to be 0. So if I have 0 over 0, I know I have a hole, and I know I have a limit. Therefore, I can break this up. I'm going to rewrite this as the limit as x approaches 3. 3 minus x over x, 15. It looks like we're going to have a positive 5 and a negative 3. Well, that's not quite the same, but I bet we can do a little bit of work to get that changed just by taking out a negative. So we do that. Cancel these out. We have the limit as x approaches 3 of negative 1 over x plus 5, which is going to give us a negative 1/8. Now, let's talk about a few more problems. We can also do another technique called the rationalizing technique. So here, if we want to find the limit as x approaches 0, we put in 0, we're going to have radical 1 minus 1 over 0. Well, that's not going to work out. This is undefined. So to rationalize this, we are going to multiply our numerator and our denominator by the conjugate. So we're going to multiply by x plus 1 over the square root of x plus 1 plus 1. Of course, we have to do it to the top and the bottom. So this is the limit as x approaches 0 of, and this is just FOILing. We're just multiplying through. So we're going to have x plus 1, and I want to make sure to put that in parentheses. This cancels out, so then we're going to have minus 1 over, and I'm going to leave this. I would not recommend multiplying this through because hopefully we're going to be able to cancel some things out. So this is going to be the limit as x approaches 0 of what plus 1 minus 1, that's going to cancel out. And now you can see we have x over x. So those are going to cancel out as well. So we just end up with 1 over the square root of x plus 1 plus 1. And if we put in 0 here, we have square root of 1 plus 1. So that's 1 plus 1, which is just 1/2. Nice and simple. We can do the same thing for number 9 here. We have radical 3 minus, this is going to be 1 plus 2 is radical 3, so that's 0 over 1 minus 1 is 0. 0 over 0, we have a hole, therefore we know that we have a limit. So let's multiply by radical 3 plus radical x plus 2. This is going to give us the limit as x approaches 1 of, we're going to have 3 minus x plus 2. Again, I've kept that in parentheses so that I don't mess up with my negative signs there. And once again, I would recommend just leaving that denominator. Don't multiply anything through. So this is going to give us the limit as x approaches 1 of what's 3 minus 2 is just going to be 1. So we're going to have 1 minus x, right? Those are going to cancel out. So now we just have 1 over square root of 3 plus the square root of x plus 2. So that's going to be 1 over 2 radical 3 multiply by radical 3. So I get radical 3 over 6. All right, there's our limit. We do have one more, I guess kind of two more, a few miscellaneous techniques. These don't really fall into a category exactly I want to talk about. Number 10, we want to be able to multiply this out, and really right here we have like a fraction in a fraction. So what I would recommend doing is finding a common denominator of your numerator and then basically dividing fractions. So this is going to be the limit as x approaches -1 of, and my common denominator here is going to be x plus 2. So I'm going to have 1 minus, this just obviously has to be x plus 2 over x plus 1. So that's going to be the limit as x approaches -1 of, looks like we're going to have 1, so negative x minus 1 over x plus 2 over x plus 1, which is the limit, and I think you can kind of see where this is going, of -1 times x plus 1 over x plus 2 times, if I divided by 1 there, 1 over x plus 1. You see I took out that -1 in order to simplify. So we have finally something that's pretty simplified that we can find our limit of. We got 1 over -1, so this is just going to be -1. Nice simple limit there. Finally, here we've got some trigonometry. Always want to be practicing our trig throughout. We want to find the limit as x approaches 0. Well, the limit, the sine of 0 is 0, and actually tangent of 0 is sine over cosine, which is just 0 over 1, which is 0. So we have 0 over 0, so we have a whole here. So we're going to calculate this limit by simplifying this, and I'm going to actually break this up. The limit as x approaches 0 of sine of x over, and I'm going to rewrite tangent as sine of x over cosine of x. Then of course that can be rewritten as the limit as x approaches 0 of sine of x, and if you want you can write this as over 1 times cosine of x over sine of x. These sines of x cancel out. We now have the limit as x approaches 0 of cosine of x, and cosine of 0 is just equal to 1. So that's our final limit. And that is exactly how we are going to calculate limits and evaluate them using 3 different methods: graphically, numerically, and algebraically.